the given element is compared with each element of an array from beginning, this is the beginning, till the end. If it is greater than 0, obviously we say print location. So we are going to record the value here, location. This is we are going to print as output. We have to find out the middle element of an array, and if middle element doesn't match, then we have to start the searching process, or either on right half of an array or left half of an array. Welcome to CS classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, today let us start our session with the concepts or the topics operations on linear array, linear search and binary search. Traversing a linear array. One of the operation on linear array is traversing. We have learned these definitions in our previous session. What is traversing? It is a process of visiting each subscript at least once from the beginning to the last element. So here in a data structure or in an array, have to visit all the elements, data items in an array at least once. That is the definition of traversing. Now let us look at the algorithm for this. Let A be in a linear array with LB and UB are the lower bound and upper bound. So LB is lower bound, it is always 0, and upper bound is always n minus 1. Suppose n is the length of an array. And this algorithm traverses the array A by applying the operation process to each element of A. Now look at the algorithm here. Here we are using for loop. You know that in general to work with arrays we use generally for loop. So we for loop for location equals to LB to UB. I mean LB is lower bound. It is always 0 because array index always starts with 0. So and it is upper bound. Upper bound is let it be n is the size of an array. So it will be n minus 1. Suppose if the size of an array is 5, that is n, so n minus 1 is UB upper bound here. So from 0 to n minus 1, we have to do process A of location. Here LOC, location at the first time it is 0 to n minus 1, first time A of 0. Because in the loop, you know how for loop works. Here first time it is location equal to LB equal to 0. So A of 0. Process. Here process it can be any operation. With respect to programming, we can make use of cin statement. Cin A of I or A of location. It can be one of the operation, one of the process. Similarly, if you say cout A of I, then in that case, here, lower bound start with 0 to n minus 1. First time it is A of, lower bound is 0. First time it is A of 0. You are visiting or you are accessing the first index 0. Then again in the next loop, in the next cycle or next circle, next time the value of location will be incremented by plus 1. It is 1 to n minus 1. So here A of 1. A of 1 is the next element. So next element process. Either it can be cin or cout, any other process or operation. That is the meaning of process here. So I mean the loop continues as long as the condition is true or from 0 to n minus 1. So with this algorithm, it is possible for us to access each element of an array or data item at least once. So this algorithm for traversing operations on linear array. Next operation is searching operation. What is searching operation? It refers to finding the location of the element in a linear array. There are many different algorithms, but the most common methods are linear search and binary search. The next slide, it is linear search. So one of the method of searching is linear search. So what is the definition? This is the simplest method in which the element to be searched is compared with each element of an array one by one from the beginning till the end of an array. So what is the definition here? Here, the given element, the element to be searched for, so that is compared with all the elements of an array from starting with 0 index to n minus 1 from beginning till the end. Suppose if the element is found, if element is matches or equal, then we have to find out or we have to print the location of that particular index. That is the linear search. I take an example. Let A an example of an array and elements is 10, 20, 30, 40, 50. And you know the index is 0, 1, 2, 3, 4. Now, this is a linear array. Now, I would like to search for an element 30. So, that is, I take an example here, element equals to 30. So, in this array, I would like to find out the location of the data item 30. As per the definition, what is the definition here? The given element is compared with each element of an array from beginning, this is the beginning, till the end. Here, suppose in this example, if I take n, that is size of an array, there are 5 elements, I can say size is 5. And what is the index? Index is 0, this is 1, this is 4. So, last element is n minus 1. So, within the loop starts with 0 and up to 4, this is n minus 1, n minus 5 minus 1 is 4. So, from the beginning till the end, this element, given element has to be compared with each element of the data item. In this example, first, because you know that we are using for loop for the same application here. So, here first time 30 is compared with first element, that is a of 0. We represent the index a of 0. This is the first element, index is 0. So, here 30 is compared with 10. So, if both the elements are equal, then we have to say that the element is found at the position 0. Suppose if these two are not equal, means in this example 30 is not equal to 10. So, next step is we have to compare 30 with the next element. Next element, that is index is 1. Next we are going to compare the given element with a of 1, that is next element. So, here 30 is equal to 20 is going to have to compare this. If both of the elements are equal, then we have to stop processing or we have to stop searching the elements. So, in this example 30 is not equal to 20, again you have to go for next element, that is index 2. So, next index is a of 2, that is 30. Now we have to compare 30 is equal to 30. Yes, 30 is equal to 30. So, we have to stop searching for elements further. So, at this stage, we have to note down the position P. If I say P is a position, at the position or the index 2. So, here the element 30, what you are looking for or searching for element 30, there is a data element 30 is found at the position 2. So, this is the concept of linear search. As per the definition, the given element, for example 30 is compared with all the elements of an array like this, and at last it gives us the position if the given element is equals to the array element. Suppose in this example 30 is found at the position 2. Now suppose you take another example where I would like to search for one more element that is 60. Now, let us compare 60 with each element of an array. So same process here, same logic. So first 60 is compared with first element, means first index 0. Here this is 60 is not equal to 10. Again we have to search for compare with second element, 60 equal to 20, not equal. So it goes on like this from beginning till the end of an array. So now in this example 60 is not matched with any of the element. So we have to output or we have to print the result as element 60 is not present in the given array. So this is a simple logic or a linear search. Now let us see the algorithm for the same. See, this is an algorithm written for linear search. In this example, A is name of an array with n elements. N is the size of an array. Element is ELE is the element to be searched. So this algorithm finds a location where the search element is stored or identified. Now, first step 1 algorithm, location equal to -1. At the initial stage, we have to assign the value -1 to location, because -1, if the value of location equal to -1 means there are no elements. Now, for example, step 2, for p equal to 0 to n minus 1. Here p stands for index. So we have to use for loop, isn't it? In the for loop, we have to start with p. From 0 is the first index to n minus 1. Here n is the size of an element, what we have declared now. So upper bound will be n minus 1. So from beginning till the end, we have to compare the element. So in this example, if a of p at the beginning, at the first time, p value is 0, it is a of 0. A of 0 equals to element. This is the search element or element to be found. So in this example, the given element is compared with a of 0, that is the first index. If these two are equal, we have to note down location equals to p. At the beginning, note down that we have assigned -1 to location, isn't it here? So now if any element is found, the value of location is changing from -1 to some other value. Location equals to p. Then algorithm says go to step 3. In step 3, at this stage, we are stopping searching the element further. So next, go to step 3 is step 3 in the algorithm. If location is greater than or equal to 0. Here, when location is equal to -1, the meaning is that element is not found. Suppose if element is found, means the given element is equal to any of the data item in the array, then value of location is going to change. As we have seen in the previous example, here element found at the position 2. Isn't it? The value of location equals to 2 in this example. Similarly, at the beginning it is -1, now it is going to change to some other value. If it is greater than 0, obviously we say print location. So we are going to record the value here, location. This is we are going to print as output. So element is found at this position, at the location, at the value. Else means we are going to print search is unsuccessful. It means that element not found or element given element is not present. So here, this is an algorithm here. Suppose if the element is not going to, it is not going to match, or the given element is not equal to the element at a of 0, then it's going, you know how if condition works, it's keep this, again for loop goes to next iteration, that is incremented by 1. So it goes to the value of p, it changes from 0 to 1. Next it is a of 1. Again, if these two elements are not equal, value of p is going to change to 2. So every time, at every cycle, the value of 5 will be incremented by +1. So this process will continue from 0 to n minus 1. So this is an algorithm for linear search. Now let us move on to one more method of searching, that is binary search. So what is binary search? When the elements of an array are stored in order, the best method of searching is binary search. So this is another method of searching logic, and here what the first condition is, all the elements of an array must be in sorted order. So it's the one of the condition is that array must be sorted before we proceed with this algorithm or with this logic. Now this method compares the given element to be searched with the middle element of an array. If the comparison does not match, the element is searched either at the right half of the array or at the left half of an array. Now let us take an example now. Let me take one example here. This is suppose this is A is name of an array and index 0, 1, 2, 3, 4, 5, 6, 7. And for elements, for example, 10, 20, 30, 40, 60, 70, 80. Let us take this example. Array elements, data items, index, A is name of an array. Now in this, what is the definition? Here we are going to find the given element. Suppose ELE is the element to be searched. Here I want to search for the element 70. For example, now as per the definition, here element to be searched with the middle element means first we have to compare the element to be searched with the middle element of an array. Now how do you find middle element of an array? This is as per the formula, this is lower bound LB, we say it is the lower bound, and UB it is the upper bound. In this example, lower bound is 0, upper bound is 7. So it is middle element is lower bound plus upper bound divided by 2. In this example, it is 0 plus 7 divided by 2. It is index is 3. So here, please note down, here you won't get a result as 3.5 because we have taken the data type as integer. It stores only the integer value. So the quotient of this division will be 3. It is not 3.5. Now here 3. Now 3. So I have to compare the middle element is 3. Index is 3. So here A of 3 because that is the middle element. So I am going to compare this with the given element. Now first I have to find the middle element of an array. That element here index is 3, A of 3 is 40. Now the given element I want to search for 70. Now I am going to compare 70 with 40. 70 with 40. If these two, in this example, this is 40 and I am looking for element 70. If these two are equal or these two are same, then we have to note down the location. In this example 3, so element is found at the index 3 or the position 3, then we have to stop processing. Then we have to come out of the program. That is the logic here. Suppose if these two are not equal, then as per the definition, If the comparison does not match the element, is search for either at the right half or left half of an array. So if these two doesn't match, we have to search for element either right half. Suppose this is the middle element. Either we have to start comparing from here, right half of an array, or left half of an array. How do we do that? Here, if the given element, 70 is greater than this element, then we have to search for on the right half of an array. Suppose if the search element is less than this element, then we have to search for left half of an array. So that is the definition given here. So accordingly, in this example, 70 does not match with 40. So 70 is greater than 40. So I have to search in this element. Again, how do we search again here? The same process. Find the middle element of an array once again. Now we have to find the middle element from here. From here to here, we have to find the middle element. In this example, 4 is the lower bound, 4, upper bound is 7. For second time, it is 4 plus 7, that is equals 11 divided by 2. You will get the output as 5. It is 5. Now, 5 is the element, index is 5. Now I have to compare this given element 70 with A of 5. A is name of an array, A of 5. So A of 5 is what? A of 5 is 60. Now I have to compare the 7 with 60. Again, 70 is equal to 60? No. So 70 is not equal to 60. Again, the process same. So here we have to search between. Now after this will be the middle element of an array. Again, either we have to search right hand side or left hand side within this. Please note down, within from here to here, we have to find, this is an array, this is the middle element. So from either we have to search like this, either with these two or left half of an array. So in this example, 60 doesn't match. Again, 60 is less than 70, or what I am looking for, 70 is greater than 60. We have to search right hand side of an array. Means again we have to find out the middle element of these two, or from right half of the array. So this process goes on as long as we find the given element. So this is the definition of the binary search, where we have to find out the middle element of an array, and if middle element doesn't match, then we have to start a searching process, or either on right half of an array or left half of an array. These are the 3 steps to be followed as long as you find the element of the array or the search element. As we have seen in the previous example, suppose in the example, if I want to look for an element 90, for example, I want to search an element that is equal to 90. In 90 is not present in the list, or it is not present in the given array. So output would be element 90 is not present. So this is how the algorithm. So this is binary search logic or binary search method, one of the method. Now let us see the algorithm for the same. This is the algorithm for the binary search. First, step 1, set b equal to 0 and e equal to n minus 1. B is lower bound or start index 0, and e is the last element or last index, that is n minus 1. Because n is the size of an array, so last index will be n minus 1. So n minus 1, location we have assigned the value minus 1. At the beginning, let it be minus 1. Next, because here we are using while loop, loop has to continue from beginning till the end. This is the beginning and this is the end. What is the procedure? As we have discussed in my previous slide, it is find the middle element of an array. Middle element of an array is the lower bound, and this is lower bound plus upper bound divided by 2. Divided by 2. Then the value here, element, this is the element to be searched for, or we are looking for element or position of that particular element, that is compared with the middle element, a of 2 middle element. If these two are equal, then we have to assign the middle element value of the index of the middle element to location. Then we have to go to 4. Step 4 is we have to exit, or we have to say search is, the process is over. Next one is suppose here if these two doesn't match, again next step is we have to search for the element either right half or left half. That process we are writing the algorithm here. If this here please understand we are using if else if statement. If else if statement, if this condition fails, it goes to this step here, this statement. So if element is less than a of m, what is the meaning of less than? Means the given element is less than the middle element, less than the given element. Then we have to search between from beginning till the middle element, or we have to search at the left half of an array, that is a equal to m minus 1, a equal to m minus 1. Else, suppose if the what we are looking for element is greater than the middle element, so in that case we have to search at the right half of an array. How do we do that? By assigning b to the m plus 1, by assigning the value or the index b to m plus 1, and this is in a loop. It continue as long as the condition is true. In other words, from the beginning till the end of an array, it check for the middle element. If element is found or elements are equal, then element we have to note down the location or index of the element, and if element doesn't match, then we have to search on either right half of an array or left half of an array. So this is the algorithm for binary search. Students, in this session we have learned the definition of linear search and binary search and algorithm for linear search as well as binary search. We will continue our discussion in our next session. Thank you very much.